Welcome back to the Caribou Data Science channel. I'm going to give you a very brief walkthrough of my workflow and also a very brief introduction to plotting, to importing, analyzing, and plotting COVID-19 data. You're going to be surprised when you realize how easy it is to get started in our programming. So let's get started, as we always do, by creating a new GitHub repository. New. I'm simply going to call this E-R-. Okay. So this doesn't even include -R. Let's even leave that off, just for the sake of that's all right. So we're going to come up here. We're going to create a new project. All right. Let's start R. Create a new project for base R. Version control Git. Now it's our project. So now let's go out. Let's go out and get some data. Download. 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 Now we come back over here to the file we just downloaded. Open here. And what you can see is I've already eliminated the unnecessary code. I am going to try to replace those slashes with dashes, which will save us a step. Because I know from experience that R prefers dashes rather than slashes in the date. So we could do that in R itself. I'm just going to sort of illustrate it. It's all about the results. If you can fix some problems in Excel or LibreCalc, hey, do it. Do it. I mean, do whatever you can do up to your experience level. Now let's save this. And we're going to save it as a file here. Okay. I really want to emphasize that, the only thing that matters is results. How we get from point A to point C is all that matters. Here we are. And I'm going to put the data actually in the inside the repository, inside the project directory itself. Now let's open back up R, and we can see that we got a CSV file right there. So now, since this is basic, we're simply going to use an R script. Dash center 4. That's interesting. I have no idea how that happens. That was really strange. Disease and prevention.R. Again, the most basic thing we can do. All right. So first, well, first let's just import our data and see what we got. We're reading the CBS file. The dot slash means the current working directory, so I'm keeping my data in the project directory. And there it is. Okay. So let's just do a little structure here and see what we got so far. Okay, so what you can see is the date is a character. So to fix that, all we have to do, or should have to do, is date reported. Date reported. Save, and let's run this again. Date. So let's try this again now. This is, okay, what is going wrong here? Why is that not becoming a date? Let's start over again here. This should be pretty simple. Date reported. As date. Date reported. Okay, I guess we do have to make a change in here. Equals, quote, month. It is a format issue, but let's see what happens here now if we do it again. Okay, let's try month, day, year. Read, shift. Okay, so now we got it in the date format. Okay, so let's begin with a very basic plot. Daily. Okay. The other thing we need to do is we need to select our data. So let's just say US subset df colon GUID, and it's either US or let's try this. Let's take a look at this up here. Let's do a filter, UID. So it is the US. Oh, I got the wrong thing. Oh, I know what it is. Yeah, you actually don't do it that way. You do a comma. Then you do this. Data frame. Then what you want to do your, there we go. So this is the data frame you want to subset. And this is the field and the variable you want to substitute. So we use UI. We want to pull US out of the DF data frame using a UID. Okay. Now let's start with reported, DF cases, TYPE. The type is, let's start with a B and see what we have. Let's add a brief title. -19 by. Okay. Now let's run this, and that'll appear over here. Now this is kind of strange. Let's run this again. I have to admit, I'm not really sure what is causing this, because I've never had a problem with this data set before. Well, I know what it is. Come on, you should have caught that. I'm using the wrong data frame. Okay. Okay, this looks more like it. This is the US. I'm also going to simply start with April 1st, simply because there is no activity up until almost the 1st of April. This will do a better job of filling the screen. So I'm going to say and cases greater than 0. Let's run this again. No, actually, that's not right. We want to say P or equal to April 1st. Now let's see what happens here. Don't understand that. Let's run this again. This should work, but it doesn't. Oh, see what the problem is? See what the problem is? I had an equals followed by a dash. You'd be surprised how you can look at something like that and look and look and look and not see anything. Okay, so I'm using April because that's really when the activity started. So so you can see what in 3, 4 lines of code we just created a plot. It really is that simple. We want grids? Well, yeah, we want grids. We're going to copy this. We're going to change this to death. Change this to death. And run these again. Okay. Deaths. You can see here. Here's our deaths. Right? These are deaths by date and cases by date. You can see faint lines in the background. I added a grid pattern. What happens if let's try it. Because sometimes what happens is let's do this. Let's just compare these two plots. B means both lines and points, so you can see that the death is still just a line, but you do get some. You can see the peaks and valleys this way, which I think is possibly more useful. Good news is cases is falling. Uh, Deaths are holding steady down here, this and down here. So now we got two very useful plots. Uh, let's say we want to do a very rough estimate of the death rate. In other words, the percentage of cases that result in deaths. Okay, that would be death rate is equal to. Now it's not, we want to calculate for the U.S. only. E is equal to U.S. colon deaths divided by U.S. colon cases times 100. Plot U.S. colon date reported, comma U.S. colon main title. Okay. Let's do this. Well, this should be the death rate. So you can see that the maximum death rate back in mid-April was above 15%. The current death rate is below 5%. Keep out average below 5%. All right. Let's add grids here. Let's just take a quick look here at. I know you can change the color of. Okay, we're going to change the color COL equal black. Let's just make one change to the. Okay. So let's just run this all again and see what happens. Everything ran. Here's the death rate, percent. Now, I'm not actually sure why that happened. How come we're not getting the main title? Because MAIN. Again, you see the little detail, it's easy to overlook. So let's just run this one here again. First, let's take a look at deaths by date, cases by date. Look at that. Okay, now we're back to our percent. And you can see now exactly what happened here. The death rate percent has declined from a high back in mid-April. It's even lower than it was even a month ago, back in July. Here's the thing. We know the death rate percent was a max of 15. If we subtract the death rate from the max, maybe we'll say that for another time to estimate the deaths. For now, show you just one more thing here real quick. And this is where you really see the simplicity and the power of R. There's two ways of tracking COVID-19 data. There was a daily number, which is what this is, right? Which in this case, for each day for each country, all right, for each day for each country. So on August 18th, there was in the United States there was a total for August 18th, 35,056 cases and 445 deaths. So this is a total for that day only. But there is a second way, actually more common, and that is using a cumulative total. So it would be, for instance, the total number of cases from say January 23rd up until August 18th. Okay. So that date range is for each day. It's a cumulative total from the first case of death to the current to that date. Now, like I say, both the U.S., both New York Times and Johns Hopkins University, both use cumulative totals. But what I show you is how easy it is to produce a cumulative total in R. Okay, that's not being spelled right. Cumulative totals. Okay, so US colon C. Let's see if this works. Cumulative sum US colon cases. Let's just get crazy and see if we can now plot this. US colon 8, comma, US colon. Let's see how this works. Okay, let's see if this works. You know what we probably need to do first is, in this case, you probably need to sort the data. All right. Okay. So let's try to sort the data first. US. So how do we sort cases? Okay. What happens if we sort this? Let's do the obvious. Let's do that's a little better. That's a little better. You need to sort your you need to sort by date. It's that simple. And so now you can pretty much see what is for the U.S. The rough cumulative curve. Uh, you can see really steep uh, exponential growth here. But according to this, it has leveled off a little bit. So has the curve been, here's the thing, okay? So now let's do the same thing for deaths. Let's plot the cumulative total for deaths. Okay, now let's calculate this and this. And now we have cumulative deaths. Again, not a particularly elaborate plot, but nonetheless, it does give us some, both sides of the picture. Uh, let's just add grid. Let's just give this a title. Now, again, we've actually accomplished quite a bit in less than 30 lines of code. There are other things we could do. We could, for instance, try to estimate the number of lives saved, which of course would be uh, the difference between the maximum death rate and the death rate for that day. But again, the main thing I want you to see here is how simple and easy that is to perform basic data cleaning, data import, data cleaning, and plotting. Okay, in R under 30 lines of code, and you've already got a good start on trying to understand the COVID-19 numbers, both as a daily number and as a cumulative number. All right. Of course, the other thing is, all you got to do is change that to get a different country. Let's see. Let's see if we can do Great Britain. Oh, now of course we should be able to. Oh, it's UK. So let's just take a look. Let's just take a look at the UK's number. We'll leave it there for the same, but you understand. Run our code again. Let's see. This is, of course, cumulative deaths for Great Britain. A very distinct curve. Cumulative cases for Great Britain. Again, for all our talk, you got problems. Now, of course, I don't understand how this. I honestly don't understand how you have a negative uh, death rate. Because if that's correct, you have a 100% death rate. Okay, deaths by date, UK deaths by grade again. How do you have a negative death rate? Are people being raised from the dead? UK cases by date, obviously a decline. Well, that's nice. UK deaths by date. Do you really have no deaths? You have negative deaths? But again, all we did is make one simple change. So I hope this has been both encouraging and helpful to help you to go in, dive into the COVID-19 numbers on your own, and learn a little bit of R. The last thing we have to do is update our GitHub repository. Let's see. Okay. Okay. Thanks so much for joining me today, and don't forget, it mean a lot to me if you would click on that red S button, bottom right hand corner, and subscribe to the channel. Also, if you have any comments, suggestions, or requests as far as what kind of reports you would like to see, include them in the comments down below, and I'll see what I can do for you. Thanks so much. Have a great day or evening.